Hey y'all, let's take a look at two things today, some geometry and then some square root stuff, but a little bit of a longer lesson today, so hang with me. All right, interior angle measures of a triangle, a quadrilateral, and a pentagon. Well, let's look at this. So here's a triangle. Interior angle measures, we already know this plus this is 180, right? All right, a quadrilateral, let's just do a square. A perfect square, it's ridiculous. Okay, if these are all right angles, let's just assume they are. We got 90 plus 90 plus 90 plus 90, that's 360. A pentagon, let's go 1, 2, 3, 4, and then 5. And what we could do is we could say, well, let's look at the first two. Here's the rule. I'm just going to skip right to it. The number of the measure of all the angles inside a polygon. All you're going to need to do is take the number of sides, okay? You're going to subtract 2, all right? Then you're going to multiply that entire thing by 180. So a triangle has 3 sides. You subtract 2, that's 1. 1 times 180, 180 degrees. If it's a square or any 4-sided figure, you have 4 sides. That's going to be 4 sides minus 2 is 2. 2 times 180 is 360. This is a 5-sided figure. So what's the total measure of all the angles, interior angles? It's going to be 5 minus 2, which is 3, and then 180 times the 3, which is 540, and there we go. That's all there is to it. Okay, we could prove this in a long way, but we won't bother right now. Exterior angles, and by the way, you need to write that down. Make sure you know this. You know how to do that, because that's going to come up a lot of times the rest of the year. Exterior angles, we could do the same thing here. Let's just say it's a triangle. No, that's horrible. All right, let's pretend it's an equilateral triangle. All right, so here's an equilateral triangle. I'll try to make one, which means this is 60, this is 60, and this is 60, right? So this is 60, then what's this angle right here? It's 120, right? Because this is a straight angle from to there. So that's 120, all right? If this is 60, then this is also 120, right? And if this is 60, then this is also 120. So it's 120 times 3. The exterior angle's 360. All right, we'll take a square again. All right, of course, that's 90, 90, 90, and 90. We can do the same thing, right? Well, this is 90. Well, then this is going to be 90 degrees. And then, another 90 degrees. And then, look at there, another 90 degrees. And then, look, another 90 degrees. And 90 times 4 is 360 degrees. All right, you can take a pentagon, 5-sided figure. And let's pretend this is, I don't know, let's say it's all the same. So this will be, if they're all the same, if they're 540 degrees, remember, if we did 5 sides minus 2, that's 3 times 180, that's 540. Well, 540 divided by 5, which is the number of angles, that means each one is 108. So that means each one of those exterior angles is 180 minus 108, which is 72 degrees. Now, if you did 5 of those, 72 times 5 is 35 plus 1, 360. There you go. So, excuse me. All right. I needed that. Okay. Well, you can see what's happening here. Doesn't matter how many sides you have in a polygon, the sum of the exterior angles will always be 360 every single time. All right, make sure you know that. Interior, subtract 2 from the number of sides, multiply by 180. Exterior, always 360 degrees. And we'll use that to find this. So if you want to copy this down, it's also in your book, but let's just look at it together. Find x and y. Well, this is a, I don't know, 1, 2, 3, 4, 5-sided figure. It's kind of wonky looking, but who cares? All right. Well, inside, let's say outside first, we know the exterior angles, the sum will be 360. So we have 65 plus 50 plus 40 plus 80 plus x plus 55 plus x is going to be 360 degrees. So we have x plus x, let's make that 2x, plus 55 plus 65 plus 50 plus 40 plus 80, that all equals 360 degrees, right? That's the exterior angles. So let's see, we got 2x, what is this, 120, and then it's going to be 90 more, that's 210, 210 plus 80 is 290. So 2x is going to be 360 minus 290, which is 70, so x is going to be 35. All right, and there we go. That'll be 35 degrees. This will be right here. This will be, that we need this to tell us what y is, because y plus x is a straight angle. Well, x plus 55 is 35 plus 55, which is 90, which means this is also 90, because 90 plus 90 gives you 180, and that's how you solve that. All right, let's very quickly look at quadrilaterals. Remember the inscribed angles deal? Remember this, where you said, like, well, let's say first, let's do, here's a central angle, right? Like, there is a central angle, and let's say it's, I'm just making this up, 100 degrees. If it's a central angle, and if the angle is 100 degrees right here, then that means it's going to intercept 100 degrees worth of the arc of the circle. Remember that kind of thing? Okay. The other part was the inscribed angle, where the vertex hits the other side of the circle. So it looks like this, kind of like, and then like that. And we knew that if, let's say this is, I don't know, 30 degrees, I just made that up, then in this particular case, it's not going to be 30, it's going to be 60. Okay? All right? Here's another kind of a funky thing for you before we get to this. Let me draw these. Let me draw two. Let's go with this. We'll say yoink and like that, okay? And let's say that this is 80 degrees, okay? 80 degrees. Well, we know that from here to here will be 160 degrees, right? Well, what's left from here, from here all the way to here, how many degrees are left just in this bottom part right there? Well, 160 from 360 will give you 200, right? So in other words, the arc measure from here all the way around to here is 200. I didn't quite get that right, but anyway. Well, if that's 200, and we did, you know, an angle like this that intercepted that, in other words, I'm just going to write this in different colors so you can see it better. But my question to you is, if we figured out that from here, you know, all the way to there is 200 degrees, well, what does this angle have to be then, if it's an inscribed angle? It has to be 200, right? Excuse me, it has to be 100. Because it opens up 100, it's an inscribed angle, the amount of arc it intercepts is twice as much as the angle, okay? Now you notice the 100 and the 80, okay? In other words, we've taken care of the whole circle, right? We've inscribed the entire circle arc. Well, it's exactly half of 360 degrees, so here is a principle for you that you're going to need to use. If a quadrilateral, that's a quadrilateral, it's a four-sided figure, right, is inscribed in a circle, the sum of the measures of any pair of opposite angles is 180 degrees. And that's it. There's two inscribed angles. Basically, there's an inscribed angle, it's 100 degrees, which means this has to be 200. Here's an inscribed angle, it's 80 degrees, which means right there it has to be 160, okay? So that's it, which means the whole 360, the opposite angles have to add up to half of 360 because each one is half of the inscribed arc. And that's it. So if you have a problem like this, find x, y, and z. Well, x is opposite of the 80-degree angle. The 80-degree angle, you know, from here right to there, that's, excuse me, it won't be to there, it'll be from here to there. That arc is going to be 160 degrees, which means the other part of the circle arc from here to here is going to be 200 degrees, which means the x that inscribes that is going to have to be 100 degrees. It's opposite from the 80, that means it has to add up to 180. Opposite angles add up to 180. Boom, there you go. Y is opposite from the 75-degree arc, right? Okay, and let's just say you couldn't remember how to do this. You could go, okay, this inscribes 75 degrees, so that means from here to here is 75 times 2, 150 degrees, which means 360 degrees minus 150 is 210 degrees. And then what kind of angle inscribes 210 degrees? Oh, I just divide by 2, that's 105 degrees. Oh, I got 105 degrees. Of course, you could have just remembered 105 plus 75 is 180 as well, but it's okay. Let's take a look at Z. Z is the arc from here to here. All right. Well, they give you. Hang on, let me erase this stuff here. All right. Z is from here to here. They already give you the 80 degrees. That cuts from here to here. That cuts into 160 degrees of the arc, right? If they already tell you from here to here is 50 degrees, which they do, that means that the Z has to be 160 minus 50 or 110 degrees. And that's it. Okay. Second part of the lesson is called fractional exponents. Let's take a look at these. What's the answer to that? 4, right? Okay. 2 to the first power? 2, right? 2 to the 1/2 power? 4. 2 and 2 to the 1/2 power? By definition, and you need to make sure you know this, by definition, in other words, what we've done here is we've taken the square root each time. All right, if we go down 1, and if we go down 1 for an exponent, we took the square root of 4 is 2, then we go, oh, the square root of 2 is just the square root of 2. So by definition, anything to the 1/2 power is the square root. Now, the way you know this, and I'll show you in just a second, a good way to do this. If you want to write this down in your notes, you should be still doing your notes like this, and then going 35, and then so on. This, I would write in my notes, okay? Write this. 2 to the 1/2 power equals that. If you will memorize that, that'll get you through a world of stuff. In fact, it'll clean and straighten your teeth as well if you concentrate enough. Anyway, you can see what's happening with those numbers, right? This gives you a fraction. Well, the fraction, the numerator is underneath the radical. The denominator is outside the radical. It'll work every single time. You can transform any number from here to here, or you can transform this kind of number with a fractional exponent to this. And I'll show you a couple of examples of those. We're not going to go missing numbers from square root of 9. We'll just hold off here. But let's look at this. By our definition, 2 to the 1/2 power is equal to the square root of 2 to the first power, and then there's an assumed 2 on the outside, right? Let's copy exactly what they do on this to what happens here. So this is going to be x, and then underneath the radical, that's the number that goes on the top of the fraction. So it's x to the 10, and then on the bottom, this 2 is outside, so this 2 is going to be on the bottom of the fractional exponent as well. So this, by definition, is x to the 10/7. You can see what the 7th root of x to the 7th would just be x, right? Because x times 7 times. This is going to be a little more than x to the first power, right? And 10 divided by 7 is a little more than 1, so this will be a little more than x, right? Let's do a couple more of these. The 4th root of x to the 9th. Well, just follow the pattern. That'll be x to the, and then 9's on the top, and the 4's on the bottom. That's all you write it as. You can deal with fractions, right? And it's not that big of a deal. You just memorize how to do this, okay? The 5th root of 6, there's another one. Well, you're just going to write, 6 here. And what number is assumed to be right here by the 6 if it's not there? It's a 1, right? Okay, so that goes on the top, and on the bottom, that's going to be a 5. Now, you notice, I don't know if you notice this, but like if somebody says to you the square root of, 11, you would go, okay, that's 11 to the 1/2 power. And you assume there's a 2 there. And if somebody were to say to you, oh, the cube root of 7, you would say, oh, that's 7 to the 1/3 power. And if somebody says to you, oh, the 5th root of 6, like we just did, that's 6 to the 1/5 power. You'll get faster at those and right away recognize what they are. This is just a matter of memorizing how to transform these into the right place in the fraction. That's all. It'll take you about a week. You'll be done with it. Okay. All right. Let's do a couple more here. Y to the 8th power, the cube root of y to the 8th power. You tell me, what's the answer? It's y to the 8/3, right? Don't worry about doing stuff with this right now. We're just getting fractions. Okay, here's another one. The 7th root of a to the 12th power is going to be a to the what power? 12/7, right? All right. You see that that's going to be a little more than a? Because a to the first power is just a, right? In other words, a to the 12th power is a. But that's because 12 divided by 12 is 1. But 12 divided by 7 is a little more than 1, right? So this value of this will be a little more than just a to the first power. Okay. All right. How about this one? 4 to the 11th root of 4 to the 23rd power will be 4 to the 23rd 11ths. There we go. Whatever that is. We don't even care. Okay. You tell me the answer to this. What is x to the 5th times x to the 3rd? X to the 8th, right? Good. All right. How about that? What would you do? Same thing, right? You just add 1/3 plus 3/4. You would probably go something like this. So the common denominator is 12, so 4/12, and then x to the 9/12, and then that'll be x to the 4 plus 9 is 13/12. Now, quick question. Could you write this as a number underneath a radical? Sure you could. In other words, can you turn this into one of these? Instead of we're going to go backwards, in other words. Okay, we could take this and go, oh, this a to the 12/7. Now, could you take a to the 12/7 and turn it into a fractional, a square root problem or a root problem? Of course you could. Just go backwards. So same thing here. If you had x to the 13/12, you would just go, okay, x there, then the top number goes underneath, and the bottom number goes here, and there we go. Okay, the 12th root of x to the 13th. That's all you do. Go back and forth. Okay. We did that one already. Okay, how about this one right here? What's the rule when you have a power brought to another power? You multiply, right? So a half times 3/4 is just 3/8, right? And that's all there is to it. How about this one? X to the -5. You know what the answer to that is, right? Okay, well that's just going to be, by definition, 1 over x to the +5. If you want to think of it this way, you just go down there, you move it. This turns into a positive x. No, excuse me, the x stays the same, my bad. The exponent turns into a +5. You have to have something on top there, so there's a 1 if there's nothing else there. That's it. Okay, you know how to do all of these. All we're going to do next is just combine this stuff here with what you already know how to do, that you've done before. That's it. Okay, let's do a couple of these. 4 to the -1/2 power. All right, pause and copy that if you need to. Okay, well, what I would do if I were you is just go, okay, well, that's going to be over a 1. Just make it real simple for yourself. Now, you know how to do negative exponents, right? You just go down there, and that turns into over 4 to the 1/2 power. That's nothing new so far. Remember, you're just moving it down and changing the sign of the exponent. There's nothing new at all. Okay, now the only thing new we're going to do is go, okay, I'm going to change this into a square root. I'm going to go keep the 1 the way it is. I'm going to turn this into a square root. The 4 goes here. Now you tell me, where does the 1 go and where does the 2 go? Which one goes there? The 1 goes there, right? And the 2 goes here. In other words, it's the square root of 4. That's what we're asking. 4 to the first power is just 4. Well, the square root of 4 is 2. So there you go. Okay. And you're going to get very fast at looking at this kind of thing. You're going to go 4 to the 1/2 power. Oh, that's just the square root of 4, 2. Oh, 9 to the 1/2 power. Oh, that's the square root of 9, 3. Oh, 100 to the 1/2 power. Oh, that's just the square root of 100, 10, and so on. Now you're going to also go like this. Oh, 8 to the 1/3 power. You're going to go, wait a minute. That means the square root of 4 is 2. So that's the cube root of 8, that's also 2. And you'll go, oh, 27 to the 1/3 power. Oh, that's just the same thing as this. Let's see, 27 to the 1 power, and then the cube root of 20. Oh, that's just 3. You'll get pretty fast at that. So we'll do a lot of those in the future. So, all right, here is one example, just like that. Okay, now this looks horrific when you see it at first. Look at that piece of trash. It's horrible. Look at it. This is the kind of thing like if you ever, I don't know if you ever get a new book and you open it and you go, oh, look at this giant history book I got to go do all year long, or like a science book, and you go, oh, I can never do this. This is the kind of thing if you ever accidentally to turn to this page and go, okay, that's it, I'm quitting. I'm going to become a hermit and just wander the freeways, just a lonely life the rest of my life. But anyway, you can do this. Knock this thing over 1 immediately, okay? Next thing you're going to do is just flip it. Yoink, down there. You got to have a 1, but don't forget, keep that sign, -27, only change the 1/3 to a +1/3, okay? Okay, now let's change this into not a fractional exponent, but let's change it into a square root. So this is going to be still 1, of course. And this will be the square root of, or excuse me, this negative 27 here. And then don't forget your 1 goes there and your 3 goes there. So the question they're asking you is, what is the cube root of negative 27? Well, what number times itself gives you negative 27, or excuse me, times itself 3 times gives you negative. And of course the answer is negative 3. So there, that's it. That's all you do. In the back of your book, you might find because a positive divided by negative is a negative, you just might, it'll probably be this is your answer. That's fine. There's nothing to this. I mean, do you know what roots are? You can figure roots of things. You already know how to do this part. You've already done that before. The only thing kind of funky looking is this thing with a fractional exponent. And you just learn immediately that, okay, you rewrite this as a 1 on, underneath, or the top goes underneath and the denominator goes outside. After that, you got it. Shouldn't be that big a deal. Okay, here's another one. 16 to the 3/2 power. Now, quick question for you. What is 16, before we do this, what's 16 to the 2/2 power? The same as. It's 16 to the 1 power, right? 2 divided by 2 is 1. Well, 16 to the 1st power is just 16, right? So we know 3 divided by 2 is more than 1. So we know the answer we're going to get to this is going to be more than 16. Okay, and you can look at this and go, okay, well, let me try this way. I'm going to go the square root of 16, and okay, let's see, 16 to the 3rd power, and then the square root of 16 to the 3rd power, Now, if you want to use your calculator, feel free. If you wanted to go ahead and go like this and go 16 times 16 times 16 is going to be, if you were to do it out, it'd be 4,096. And then you could type in your calculator, what's the square root of 4,096? And you would get the answer is 64. Let's say you had no calculator. What you need to do then, and if you want to write notes on this somehow, put, I don't know, something like turn into smaller number. And those 3 exclamation points indicate urgency or loudness as you shout this to the computer screen. All right? 16, blech to that. Forget it. Let's try something different. Now, a 16 is a power of 4, right? It's 4 squared. 16 is also a power of 2, right? So you can go as long as, let's go down as far as we can, all right? So 16, instead of writing 16, we can write 2 to the what power? 2 times 2 is 4, then 8, and then 16. So that's 2 to the 4th power, right? Okay, well, now let's go ahead and, since this is 16 to the 3/2, let's go 2 to the 4th, to the 3/2 power. 2 to the 3/2 power. That okay? Now you already know the answer to this, right? What's x to the 3rd brought to the 8th? It's x to the 24th, right? Because you multiply. Well, what is 4 over 1 times 3 over 2? It's 12, right? Divided by 2, which is 6, right? So what we have is this is 2 to the 6th power. And the answer to that is 64, if you were to, go ahead and do it all the way out. And there you go. Okay. That's all there is to it. All right, let's try another one. Oh, how horrible this thing looks. Look at that. That's trashy looking. Whew. All right, negative 8 to the negative 2/3 power. Okay, well, let's put it over 1. Now let's chunk it down here. And we got a 1 over, keep your negative 8 the way it is, and then put to the positive 2/3 power. Okay, that okay? All right, well, let's go ahead and transform this thing. Well, let's see here. We got a, square root there. There's an 8, negative 8, excuse me. All right, so this is going to go, the 2 is going to go there, and the 3 is going to go there, right? Well, what is the opposite of 8 squared? Well, the answer is negative 64, right? And what number times itself 3 times gives you negative 64? Well, of course, the answer is negative 4. And that's it. Here's your answer. Okay. That's all there is to it. Okay. All right. Give those a whirl. Let's do A and go ahead and pause it and come back. Okay, the rule is, don't forget, the interior angles, you take the number of sides minus 2 and you multiply it by 180. All right, a 14gon is 14 minus 2, which is 12. So 180 times 12 is 2,160. That's the interior angles. All right, pause it and try B. B, you shouldn't have to, you don't even have to do anything. You just have to say 360. Because if the thing is, it doesn't matter. Exterior angles, doesn't matter if it's a shape of, as long as it's a polygon, it could be, you could look at it and go, that looks like my Uncle Dwight. Doesn't matter. It's still, the exterior angles is going to be 360 degrees. Boom, you're done. Okay. All right, pause it and try C. Pause it and try C. Okay, what I like to do is, put this over a 1, and then I'm going to rewrite it. And I'm going to have 1 on top now, and this goes down here. It stays at 64. This turns into positive 1/2. And if you didn't recognize immediately or remember that, oh, anything to the 1/2 power just means the square root, that's going to be 8. It's okay. All you need to do is just rewrite it as a square root. The 64 is there. The 1 goes right here. You don't even have to write a 1. Don't even bother to write 1. But write a little 2 there, yoink, and that's a square root. Well, the square root of 64 is 8. That's all there is to it, okay? All right, pause it and try D. All right, very quickly, 64 to the 1 power is 64, right? That's 64 to the 3/3 power. You should recognize that this answer, 2/3, that's not quite 64 to the 1st power. So the answer won't even be as high as 64. It's going to be less than 64. So that's something to kind of think about very quickly. All right, well, 64 to the 2/3 power, I would, you can rewrite 64 as an 8 squared. You could rewrite 64 as a 2 to the something power. In other words, you don't want to, this is what if you did this, this is correct if you went like this. If you said 64 squared, which is 4,096, then you went, okay, what's the cube root of 4,096? Oh, 16. That's correct. You would be correct. But pretend you have no calculator at all. Pretend you have no calculator at all. What I would do is rewrite the 64 as a power of 2. Get it as low as you can. Knock it as low as you can. 2 times 2 is 4, 8, 16, 32, 64, right? So instead of writing 64, just write 2 to the 6th power. Replace it. Then you're going to bring that to the 2/3 power, right? So we know if we bring a power to a power, we multiply those numbers. What is 2/3 of 6? 4, right? And if you didn't remember that, you could just do your fractions. 6 times 2 is 12. 1 times 3 is 3. 12 divided by 3 is 4. So 2 to the 4th power, 2, 4, 8, 16. Boom, there you go. Okay. Try E. That's an ugly one. Give it a shot anyway. Okay, pause it. All right, first thing I do is to cancel some of the yuckiness by kind of clumping it down there and going negative 125 to the positive 2/3 power, okay? Well, again, you could go, negative 125 to the 2/3 power. This is looking kind of ugly here, but you should recognize that the 125 is a power of 5. All these numbers they give you are going to be powers of something else, 2, 3, 4, 5, whatever. They'll probably stop about 5. This is nasty, but if you look at it as a power of 5, you go, this is a little easier to piddle with. Now, I do want to make sure real quickly, first, you could do this if you wanted to. You could say, okay, negative 125, and then that's this, and then the cube root of that. So what's the opposite of 125 squared? 125 times 125 is, oh my goodness, 15,625. I don't think you want to find the root, the cube root of 15,625. But, you could. That would be the opposite of that, excuse me. Let's just forget this. Let's take this 125 and turn it into a power. Well, 125 is 5 times 5 times 5, right? Okay, so keep your 1. do your negative and then go 5 to the third power and then bring that to the 2/3 power, right? That good? That makes sense? Okay. Now you know a power brought to a power, you multiply. So look, you can cancel this out. Gone. So on top you still have your 1. You still have, now you have a 2, so you have the opposite of 5 squared, which will be -25. And there you go. That's all there is. Okay. All right. Hope that helped. That was a long one, but good luck today. Knock those out, and see you guys next time. Have a great day.